All right, so we're going to be drawing DT graphs, position time graphs from the description. So remember, stuff you learned in grade 10, movement to the right is positive slope. When it's a straight line, what does that mean? Right? What does that mean when it's a straight line? Constant speed, Megan's right. Constant speed, right? So this would be a car moving to the right at a constant speed. Movement to the left is negative, right? And the straight line tells us that they are constant speed. Okay. I guess I'll do a copy of that. Oh, and you guys have to fill in something there, right? See that blank? If you follow along, you should know that there's a blank already. What do you need, Grace? Okay. Okay, constant velocity. Okay, so what about speeding up and slowing down? This is all kind of, excuse me. This is all kind of reviewed in grade 10 a little bit, just expanding that grade 10 knowledge a little. So accelerating to the right. In fact, some of you that had me might even recognize the yellow bug Volkswagen, right? How can I tell if something is accelerating? The space between them is getting larger, right? Do you guys put anything down there? No, I don't think you do, right? So you can see that it's going farther each second. It is accelerating to the right. You've got the next one right in front. Oh, but you don't have that, do you? You need to fill that in on the right-hand side. So I've got a little graph there that you should be drawing right now over on the right-hand side. And what would that graph look like? Anyone remember from grade 10? Straight line? Remember, straight line is constant velocity. So, and I think we already know that the slope of the position time graph is the speed. So if the slope is the speed and it's speeding up, then that means that the slope has to be increasing, and Riley's got it. Like that, right? Increasing slope, accelerating to the right. Okay, and you should have that jotted down just on the side there. Okay, so what about slowing down to the right? How do we recognize slowing down to the right? Well, from the picture, what's happening to the spaces in between? Getting smaller. Okay, so we know it's slowing down. So if it's slowing down, the slope has to be getting smaller. What does it look like when the slope gets smaller? What do you think? Give me a hand description. Circle? The opposite of this one? Yeah. Like that, right? Curving and getting flatter. Give me the nod of agreement. Only if, of course, you agree. The nod of understanding. Oh, yeah, I get it. Yes. I'm paying attention. Excellent. All good? Okay. What about accelerating to the left? I don't have the yellow cars in there. Or do I? No, I don't. How are we going to show accelerating to the left? Ooh, someone put my chair down. I'm just going to have to draw them in. Accelerating to the left. So they're going to get... Do you guys have it? No, you don't either. We're going to have to... what does accelerating to the left mean? The space they're going to get? Bigger and bigger. Let's put the first one right here. I'm a terrible drawer. See? Savannah's laughing at me, mocking my artistic abilities. I'm come over there and I'm going to have a look at hers for a second. The spacing between the cars is getting bigger and bigger. We are accelerating to the left. Now I've got a little graph down here. You guys have to do it sort of on the side. What's it going to look like? You'll notice that my graph axes have changed a little bit here because I need negative. Let's look at the position of the car. The position of the car still remains where? On the positive side of things. right? It still remains on the positive side of things. So where am I going to put it on my graph here? Emily, the sheets are right up front here before you sit down. Where am I going to put it? Am I going to put it down below? Am I going to put it up top? What do you guys think? Up top? How come, Grady? You're right. Yep. And these are all positive, right? So in fact, this is completely wrong. This could go down there. I did that on purpose to see what you were doing, see if you're thinking. Okay? Because I start at 20, this is a position time graph, right? So I start at 20. Now, because the cars are getting farther and farther apart, that means it's speeding up, which means the slope has to be increasing, but just negatively. Why negatively? Because I'm going to the left. So how do I do this? I start off flat and I get more and more negative. Is that what you had in mind? Right? Why is it getting steeper? Because it's accelerating. Okay, this is still steeper. But the slope here is always what? Negative. The nod of understanding. I don't see a lot of that. Okay. Yes? Are you giving me a genuine nod of understanding, Karen? Okay. Slowing down to the left. How am I going to draw my cars? Slowing down. So it's going to be, they're going to be far apart to begin with, right? They're going to get closer together. Let's go there. 4, 2, 3, 2. Oh, aren't you guys using pencils? Slowing down, the distance between them is getting smaller and smaller and smaller. So what about, again, do I need the negative graph here? How come? I never go into negative territory. Just because I'm going left doesn't mean that my position is negative, right? Okay. Slowing down to the left. So the slope is getting steeper or flatter? Flatter. So it's going to be which way? Is this what you mean, Ryan? Is that what you mean? Yeah, is that what you had in mind, Talia? Okay, good. Now we're going to be doing this like real life, you know, this is like the Scooby-Doo version here, and then there's going to be like the real, you know, cartoons here, and then this is going to be like, you know, what do they call it, live action. Riley's going to come up and he's going to play with the cart. Okay. So, I have a motion detector here. Let me explain how this works. You guys know about sonar? Anybody know what the letters SONAR stand for? Sonar is not an actual word, it's an acronym. Sound, SO, navigation, N, A for and ranging. Sound, navigation, and ranging. What animal uses sonar? Whales? Maybe. Dolphins, for sure. And bats, I think, right? Okay, so what's going to happen is when I press start, whales, maybe, yeah. I don't know. You're going to actually hear the sound. The sound goes out and it bounces off the cart, and it bounces back to here, and the device records the amount of time it takes for the sound to go there and back at 330 meters per second, and then it can figure out exactly where the cart is. And it's actually going to draw a graph on the screen.
Oh, that's really
You want to see it?
Yeah.
You'd almost think I practiced that.
Probably.
I didn't, but I've done it a lot. So there you go. There is a position time graph for that little cart. Took 9.7 seconds. What do you think happened for the first 2 seconds? Right, I pressed start, and then it took me a whole 2 seconds because I'm also old to get over here and give it a push, right? And then I gave it a push, and it more or less moved at a constant velocity. And then what happened right there? Hit the bumper. It's a magnet. There's a magnet on the end. There's a magnet here. So it instantly bounced back. Did it have to slow down first? Did the cart know, oh, I'm going to slow down? No, it just kind of go, boom! Right? Bounced right back. Now on the way back, friction sort of took over and it started to slow down, right? How can you tell? And it's getting a little bit flatter, right? And then eventually it actually almost, it very weirdly kind of went from still moving to almost stopped almost immediately, right? Almost perfectly. Okay, so now you have on your sheet, you have, let me just see exactly what you have. You should have something like this, right? Okay, so it says, note that away from the motion detector is always a positive direction. Now I've set it up in this room. In my old room it kind of was weird. I had it the other way. I had to make everyone think backwards and it didn't work so good. But the cart is moving to the right, so that is positive. Where is our frame of reference that we talked about I don't know, about 4 or 5 days ago, last week? Frame of reference is where we measure things from. Where is it? Where is it? It's right here, right? This is the 0. Where's the negative part? Is it going to work negative? Are we going to have any negative positions? The track doesn't even exist over here. Okay, so everything is going to be positive position. Okay, so what I'm going to do is, it says for each description determine what the DT graph will look like. The cart was right then, so you've got a spot for a guess, and then actual, so there's no worrying about getting it wrong. Okay, put down your guess on the left-hand side, and then we're going to actually do it. So I'm going to run and do my attendance. You guys do a graph right here. Okay, under guess, you guys do that, and then I'll get some volunteers to come up and we'll play with it. It says here that the cart moves to the right and then immediately left. So you're going to go right, and then without slowing down, boom, back out. Okay, where are you going to start from? Right there? Okay. Now, if you're really quiet, you might be able to hear it. Some of you guys that are closer can probably hear it. The chip bag's going to, yeah, just... Okay, listen carefully, you should be able to hear the sound. Okay, so you've sort of already seen this one, right? Because it's kind of what I did, right? So what did you draw? What should it look like? Yeah. Now you'll notice that Carly it was flat for a little while because it took her a second to realize that I turned it on. And then it's up like that, right? And then does it come back at the same speed? More or less, right? More or less like that. So I'll do all 3. Anyone else want to come play? Okay. Now, what I actually wanted her to do, I think I didn't communicate very well with her. I wanted her to kind of go like that, right? Yeah. So you're moving it back and forth. So in Karen's case here, the cart moves slowly left, stops, and then slowly right. Yours is kind of. Yeah. But if you're going to go left, where do you have to start from? Exactly. You don't have to go that far because it has to pick it up. Yeah. Okay, so left, stop, and then back right. Okay, let's just... I'm afraid when Taryn starts driving a little more because it says the cart moves slowly left, and apparently that was slow. It was pretty fast, yeah. Okay, so should we try again? Yeah, I think maybe. Okay, yeah. And then stop. Okay, so the key part, thank you. Did she move at a constant speed? Kinda? let's just see here. And I'm not judging, Karen. We're analyzing. Okay? So here's how fast it's going here, right? And then way down here, I don't know if I can do it. No, I can't move it. It won't let me move it down. But way down here, it's going this fast. Are those the same? Not really, right? So you kind of sped up a little bit. It's okay. We're just analyzing here. So it's going a little bit faster, and then she ran into the motion detector. And is this stopped?
Yeah.
It's pretty flat. Actually, what happens is the motion detector, when you get that close, it's not near as accurate, and it might be like picking up her hand, kind of thing. So it's thinking that her hand is part of it. So that's why there's that little sort of bounce kind of thing. Some days I have to actually put like a piece of paper up to sort of bounce the sound back type thing. Did you guys hear the sound going? Could you hear that? Yeah. Okay. And then
What's the sound that's happening?
come on up and listen. You come on up and do the next one, Ty. Come on. It'll be fun. It's not that hard. Yeah. Okay, so let's just, while Tali's coming up, right? So what should you have actually drawn? Now you guys are actually going to leave your guess, right? You're going to, okay, so slowly left, it has to start up here. Slowly left is flat. Now, does it have to go all the way down to 0? I didn't actually intend for Taryn to go all the way back to 0, right? It only needed to go to up here. It was fine that she did, right? But does it have to go all the way to 0? It just has to be flat, right? So the correct answer, I guess you could say, is something like that, right? And wherever that 0 is, doesn't matter. Okay. Tali, you've got the hardest one, so I hope you've been practicing.
What?
The cart moves left. That's right. Cart moves left, pauses.
Yeah.
Want to try? Left, pause, continues left, stops. Quickly right. Excellent. You know fast and slow? It's like Sesame Street. Remember the near and far? Near?
Okay, so it pauses.
I'm too old.
It pauses.
Left?
And we keep going.
Yes.
Okay.
Got it?
Yeah.
I'll have to find Grover playing near and far. Okay, can you listen for the sound? It's like she was in here at 8:30 practice. Excellent. Okay, so it's going left, speeding up a little bit. Does it have to speed up? Absolutely, right? I mean, you'll notice here at the start it's 0. Is this curved in here, right here? Yeah, because she has to go from stop to some speed. So it's going to be curved a little bit. And then she has to start to pause, so she slows down. I'm just going to zoom in a bit here. Come on. There we go. Uh-oh. Oh, way to go, man. There we go. Oh, yeah, that's better. That's what I wanted. Okay. So she has to speed up a little bit, slows down, pause. How long was her pause? About from 2 to about 2.5, 2.6 seconds. So about 0.6 seconds of a pause. Then, now what would you say her speed is here compared to her speed before? Pretty close to the same. Right? What's this spot right here, Carly? Stopped. Did she stop longer than she paused? A little bit. We'll just leave it at that. A little bit, right? And then did she go fast back to the right?
Yes.
Yes, she did. She knows fast. Okay. All right. So now I think I've given you the graphs. I should probably do like an actual one. Cut and paste in there. I don't know why I thought that. There's an actual one. So now I want you to write the description. You've got 3 to do, right? You've got a graph. You've got 3 graphs, and then I want you to write an actual description. Okay? Okay, I'm just going to quickly give the answer. So for each graph, describe what the motion would be. So we would be moving, right, moving left, left, pause, left, right? Left, pause, left is the first one. Okay, then this one would be right, pause, left, but would you say right quickly? Quicker, right? Right quickly, pause, slowly left. You will notice that there's no curvature here. Pretty sharp corners. Okay, this would be slowly right, fast right, stop or pause, and then slow left. Okay, good. All right. So now what you've got is, you've got 5 or 6 ones where it just gives you a description. It's not a motion sensor. It's just sort of like, real life kind of thing. I want you to draw a position time graph for the following. I'm going to give you like about maybe 6, 7 minutes, and then I'll correct these, and then I'm going to give you the green sheet. The green sheet is handed to me, and I check to see they learned something today, or they didn't pay attention at all, they need help. A ball is thrown in the air, it lands on the ground at your feet. 10 seconds later, position is measured vertically. In other words, we are worrying about the height, how high it goes. Okay, so as it goes up, what happens to the speed column? Slows down, right? And then it gets to the top, and then it comes back down and starts speeding up. We are measuring the height. So now I'm giving you the answer. Now, here's still more learning. Hang on. Break's coming. So now, if you're going to throw it, it doesn't say from shoulder height, right? But most people are going to throw it from here. They're not going to get right down to the ground. So it should probably be like that. Is that what you had?
I started mine at 0 though. Yeah.
If you start at 0, then that means it's going to have to bend right down to the ground, right? Throw it up. It's kind of like starting the cart, right? There. So it should probably be a little bit higher up. Okay? But the key idea here is that the shape, right? It's slowing down as it goes up, and then it comes back down. It shouldn't be really that flat right there. Okay, now what if the position is measured in the above example horizontally? In other words, what if I'm not caring about how high it goes, I just care about how far forward it goes? Horizontal distance. Well, if I throw it up, I'm not going to throw it, I'm going to throw it off. I throw it up, but you're measuring distance this way. What is it going to be? It's going to be the same the whole time. What would be the best frame of reference? Probably me. So what would it look like? And this one always stumps kids. I'm thinking it would just be like flat. How come? Because we're measuring how far it goes sideways. We don't always have to measure height or left or right. We can measure either one. That's what I'm talking about. So it's just, right? It's whatever distance this is. Okay. A man walks for 8 minutes south from his home on Main Street, north of the Royal Bank. The Royal Bank is in downtown Dauphin. He spends 2 minutes at the ATM and then returns home. I haven't told you in any of these cases where the frame of reference is, where the origin is. Usually it's where you start. So if he's walking for 8 minutes south, now south is generally considered negative. So he starts at 0 and he walks south. He's walking negatively. He spends 2 minutes at the ATM, flat, and then he returns maybe a little bit slower because he's weighed down by all the $100 bills in his pocket. Maybe he made a deposit, maybe he won't back. Does that make sense? Are there other ways to draw it? Yes, it all depends on what you define as your frame of reference. Don't start, guys. The end of the class is always the important part. This is where everything starts to really start making sense. Don't start having conversations now. Hang in there. We got 5 minutes left. Emily.
It doesn't say south.
Oh, it doesn't say south in yours?
No.
Oh.
So,
I apologize. Fix that. A bowling ball spends 8 minutes in the rack waiting to be thrown. It takes 4 seconds for the ball to reach the pins and 20 seconds to return to the rack. Would you say the rack is 0? Okay. It spends 8 minutes sitting around waiting. It's just sitting there at 0. Then 4 seconds. Right? And then it does what? So it's a little bit slower coming back, right? not ready to scale. Something like that? A girl leaves her locker by the ops and starts to walk to the gym. She walks 15 meters before she realizes she forgot her gym clothes. She returns to her locker, gets the clothes, and then proceeds to the gym. 15 meters. Turns around, back to her locker, and then races to the gym because she's late. Does this have to be past this one?
And a pause will take.
I suppose. You could do that, yes. Megan says that. Sure.
Yeah, I can just stop.
She stops. Excellent. Got to untwist the tab on her locker, right? Do you guys have one more?
No.
Okay, excellent. Okay, so you have the green sheet now. I realize there's just a few minutes left. Please have that done for tomorrow. You can do it. Okay, have that done for tomorrow. I know it's homework. Did I miss you guys? That's good. Okay.